Okay, so I got cut off again, but this should be the last time here. Okay, so we figured out our vertex was going to be at 2.5. So I'm going to plug this in to the handy calculator. So I have negative 16. Now again, I'm going to always change whatever that variable is to an x, just to stay. I think the calculator will only read an x, so just keep that in mind if it gives you an error. Okay, there we are. I'm going to the table, and I'm looking for 2.5, but remember, what did we have an issue with here? We need to put in a decimal. So I'm changing the settings of the table to 0.5, and I want 2.5. And we are at 100. So the vertex is 2.5, 100. So what is the object's maximum height? Well, your vertex is going to be the max. So it is 100 feet. Okay, so that was fairly simple, not a lot of mathematics that went into that. So now let's take a look at Big Bertha here. Big Bertha, a cannon used in World War I, could fire shells incredibly long distances. The path of a shell could be modeled by that, where x was the horizontal distance. So I'm going to define it as we go. Horizontal distance in miles, and y was the height in miles. So two things, both in miles. Which form is this in? I think that's a pretty straightforward standard. There's no parentheses. So standard form. And then how far could Big Bertha fire a shell? So how far? So again, this is going to, I'm just going to sketch it out. Big Bertha might send it out like that. So I have those 2 points. How far? So we need to find this distance right here. That's my goal. How far could it fire a shell? Not how high, how far. So I need to find that point. Well, I can find the vertex and then just double it. So that is going to be my goal here. So I have x equals negative b over 2a. So again, I'm going to do this here. A, B, C is 0. B is 1.37. A is this nasty negative 0.0196. So when I do this math, negative B, so we get negative 1.37 over 2, negative 0.0196. And that comes out to be, already calculated, 34.95. So we'll say about 35. So that's the x value right here. X equals 35. How far could Big Bertha fire a shell? Well, if that's the midpoint between the two x-intercepts, I can double that to see the distance. So this would end up being 70. 35 times 2 is 70. So 70 miles Big Bertha. So a cannon could fly 70 miles back in World War I. That's pretty impressive. What was the shell's maximum height? So I have the 35. I just need to find that in the table to get the height. So I'm going back to my calculator, plugging in this kind of nasty thing. Negative 0.0196x squared plus 1.37x. Going to the table, and again, we're rounding it. I need to get rid of that decimal. Okay, so I'm looking for 35. So I'm going to have to go up here quite a bit. All right, and it looks like 23.94. I'm going to round that up to 24, or about 24 miles high is the answer for the shell's maximum height. So that's how you approach these word problems. We will try to do one or two or three of these maybe today. We're having a work day on Wednesday, so don't worry if this kind of went over your head a little bit. But see what you can do. Try to get a couple done today in class. All right.